Imagine waking up tomorrow and realizing yesterday no longer exists. You can't go back, you can't slow anything down, and every second is pushing you forward whether you want it to or not. Time isn't just passing, it's dragging everything with it. Now imagine standing still while the entire universe moves around you. Stars age, people grow older, and entire galaxies change, yet you can't pause any of it. This isn't science fiction, this is how time actually works. Time feels simple. 1 second follows another. Past becomes present, present becomes future. It feels automatic and obvious, but in physics, time is one of the strangest and least understood things we know. In Einstein's equations, time is not fixed or universal. It stretches, slows down, and bends depending on speed and gravity. That means time is not the same everywhere in the universe, even though it feels that way to us. Here on Earth, time moves at what feels like a constant rate. Your clock ticks, your phone updates, your heart beats in rhythm. But the moment you leave Earth, time begins to behave differently. On the International Space Station, astronauts orbit the planet at about 28,000 kilometers per hour. At that speed, time for them slows down slightly compared to people on the ground. Their clocks tick about 0.01 seconds slower every year. It sounds insignificant, but it's measurable, real, and unavoidable. Astronauts actually age more slowly than you do, simply because of how fast they are moving through space. Speed is only part of the story. Gravity changes time too. The stronger the gravity, the slower time moves. At Earth's surface, time runs a tiny bit slower than it does far away from any massive object. You don't notice it because the difference is extremely small, but it exists. Near something incredibly massive, like a neutron star or a black hole, the effect becomes extreme. Near the edge of a black hole, called the event horizon, time slows down so much that from an outside perspective, it almost stops completely. If you could somehow survive near that boundary for 1 hour, years or even centuries could pass for the rest of the universe. This isn't science fiction, it's a direct consequence of general relativity, confirmed by observation and experiment. So what is time really? Time is not a physical object. You can't touch it, store it, or point to where it exists. Time is a way to measure change. When atoms vibrate, when planets orbit stars, when your heart beats, time is tracking those changes. If nothing changed, time would lose its meaning. Imagine freezing the entire universe, every atom locked in place, no movement, no vibration, no light traveling, no energy flowing. In that universe, time would effectively not exist because there would be nothing to measure, no events, no sequence, no before or after. Time only emerges when change exists. So if time is tied to change, why does it only move forward? The answer lies in entropy. Entropy is a fundamental law of physics that describes the direction of change. It says that closed systems move from order to disorder. Heat fades, batteries drain, rooms get messy, and broken things do not fix themselves. These processes do not reverse on their own, and this one-way drift is what scientists call the arrow of time. Right after the Big Bang, the universe was highly ordered. Over 13.8 billion years, it has expanded, cooled, and spread out. As energy becomes more evenly distributed and less usable, entropy increases. That steady rise in entropy is what gives time its direction. This is why we remember the past, but not the future. The past had fewer possible arrangements. The future has many. Memory works by recording order, and order only exists behind us, not ahead of us. Entropy flows one way, and so does time. This also explains aging. Your body is not running out of time, it is fighting entropy. Every second, roughly 50 million cells in your body die and are replaced. DNA is copied, proteins are repaired, systems are maintained, but entropy slowly damages these processes. Errors accumulate, repairs become less efficient. Over decades, the damage builds up. Aging is not time passing through you, it is disorder gradually winning. But here's where time becomes even stranger. Time does not tick the same for everyone. even on Earth. GPS satellites orbit about 20,000 kilometers above the planet. Because gravity is weaker up there, time moves faster for them than for clocks on the surface. At the same time, their speed slows time down slightly. When you add both effects together, satellite clocks gain about 38 microseconds per day compared to Earth clocks. Engineers must correct for this constantly. If they didn't, your GPS location would drift by about 10 kilometers every single day. Time is literally built into modern technology. Your phone depends on relativity to work. So why can't we stop time? Because stopping time would require stopping all change, every moving particle, every vibrating atom, every flowing field of energy. That wouldn't freeze time, that would erase the universe itself. A universe with no motion is not a paused universe, it's a dead one. Time isn't a river you float down, it's the record left behind by everything that changes. Every star burning hydrogen into helium, every cell dividing, every galaxy drifting farther apart. These changes are what create time as we experience it. You can't stop time because you can't stop reality from evolving. So the next time you feel like time is running out, remember this. You are not losing time. You are watching the universe transform moment by moment as it always has. If this made you see reality differently, hit like. Subscribe to InnoVision Tech for more science, technology, and the hidden laws shaping the universe. And share this with someone who's ever wondered why yesterday is gone, but tomorrow never arrives.